morning, everyone. We are going to finish off today questions involving volumes of revolution. And this time we're going to look at revolving or rotating about the y-axis. Should put down what section this is. Well, we already did rotating about the x-axis. So what's the major difference? Not much. Imagine you've got a curve like x equals y cubed, x equals y squared plus 1, whatever it may be, this curve here. And you rotate it about the y-axis. Can you see you would make, I don't know, it would look to me something like a solid bowl. You know, it would have a kind of shape, something like this. Oops, okay, I'm not good at being on that straight. Right, with the y-axis going through the center. So how do you find the volume of such a shape as this? Well, isn't that remarkably similar to the same formula when you rotate a single curve about the x-axis? And the only real difference is that guy, right? So it's pi, the integral from y equals c to d, right, the start and the finish in terms of y, of the curve written down in terms of y, all squared dy. So as I say, there are only 3 questions. I believe there's 2 questions where it's a single curve and 1 question where it's the area between 2 curves. And so the first one I'm going to do is similar to question 5. Show you what it looks like. We're being asked to find the volume. The curve is 4 the square root of 5y. It's got x equals 0, it's got y equals 3, and it's going to be rotated about the y-axis. Now, if you find it difficult to sketch functions that are like this one here, and what we can do is use Desmos. So let me show you how that would work. X equals 4 square root of y gets you this fella. X equals 0 is this vertical line, and y equals 3 is this line. So the shape that we are rotating about the y-axis is this shape here. So I'm going to draw a little baby version of that. And it looks something like this. You get a guy here. You'll see this in a few seconds. That fella. The guy here, y equals 3. And this is the guy that's going to be rotated about the y-axis. So you put it into your calculator, put it into Desmos, you see what it looks like, and that should help you to set up the integral in the correct form. So this is the shape that we're going to rotate about the y-axis. It starts at y equals 0, and it finishes at here, which is 3. There's my pi, and the f of y is this fella, squared. So pi, start 0, finish 3, the function squared dy. You comfortable about where all those pieces came from? So let's take it to the next stage then. If you take 4 times the square root of 5y and you square everybody, don't you basically get 4 squared, the square root of 5y squared dy? I'm taking this slowly, just so you can see everything that's happening. 4 squared is 16, and that guy gets you 5y. Because if you square a square root, you get what's inside. And this fella gets you 90. And then I can do the power rule. Add 1 to power and divide by the new power. And 45 times 3 squared, take away nothing. So 45 times 9, 405 pi. So draw a picture so you're aware of the start and finish value of y and what the function is called. That allows you to generate this. And then from this line onwards, it's really just integration in the usual way, except the variable's called y instead of typically x. But we've done questions where the variable was t and when it was u, so I don't think x or y or any other letters any different. It's the same, you know, power rule, whatever you need to make it happen.
Just a quick question. Isn't 16 times 5 80, not 90?
Oh, did you all catch that deliberate mistake? Yeah, you're right. Here we go. Moral of that story, use calculator. Well, that's 2 of the 3 questions that you're going to be doing in your homework. This is the final kind. Suppose this function is called f x equals f of y, and that this function here is called x equals g of y, and that we're taking the area between 2 functions, which is essentially this thing, and it starts at c and it finishes at d, and we're being asked what would the volume of revolution be if you rotated that shape about a y-axis. Now we did that at the end of yesterday. So the formula is going to be pi, the integral from c to d. Can anybody remember what goes here? We did something very similar with x's yesterday. F of x and g of x.
So f of y squared minus g of y squared?
It is exactly that. Now, isn't that just like f of x squared take away g of x squared? Remember the questions that looked like that? We're just doing questions that rotate this way. But the math is very similar. So using that formula, we don't have too many questions on the homework to do that with, but I'm going to try and find the last one. Here it is. So this is question 7. And we have a y squared equals 2x. That's one of our curves. And it's an x equals 2y. And it's the region between them. And it's going to be rotated about the y-axis. So I'm going to move over now and use Desmos again. And we'll see what that region, or those 2 regions intersecting with each other, look like. Okay, first equation is y squared equals 2x. I don't need to do anything algebraically. Desmos is pretty clever. There's y squared, there's equals 2x. It's that green curve. And the next one is x equals 2y. Oh, right, I don't actually need a third one. Do you see that the area between them is this? No, it looks like an upside down boat kind of shape. That point there is important. It's got coordinates 8, 4. And this point down here, which is kind of obvious, is the origin. But I'm going to draw a very basic copy of that shape. So we have a guy that looks like a curve, and the curve was y squared equals 2x. And then we had a straight line, and it was called x equals 2y. And we had the origin, and let me get that point again for if I get 8, 4. So this is 8, but that's 4. And we are being asked to rotate the shape about the y-axis. So I should have everything in my little sketch now. In one of my earlier classes, one of my students was asking me about what they should really be doing as far as working is concerned. If it's normal homework questions, you don't need to put everything that I'm doing here. These are here for kind of reference to show you the whole process. Can you imagine just looking at the Desmos picture so you don't physically need to write this one down, for example, right? So you skip all those little corners. And you know how sometimes I take 5 lines to do something that you could do in 3, right? For homework, you should do that. But when it's a test question, will you draw that picture? Because I don't know what you saw in Desmos. And will you show me the 5 lines in case you screw up in one of them? At least I can see what your process is. So in general, in homework, you can cut as many corners as you feel comfortable with. But in a test situation, try and write everything that you possibly can. Right, we got the guy set up. Let's see what the volume looks like. Since I'm rotating about the y-axis, I'm going to use 0 to 4. That 8 isn't necessary. In fact, I'm never going to use it. Now, when you do a y-axis guy, your line goes this way. And the guy that's going to be called f of x is him. And I should say f of y. And the guy that's going to be him is g. The further to the right is the big one, right? So the straight line in this case says x equals 2y. So that goes there. That's essentially my f of y. And then I square it. Take away. Well, I'm going to do g of y squared. But I have to be careful here. This question or this equation was written in the form y squared equals 2x. If you need to, you may have to change one or both of your equations. Doesn't it have to be called x equals a function of y, not 2x equals a function of y? So that's why that's a half y squared. Now that becomes pi, the integral from 0 to 4. 4y squared, take away 1/4 y squared. No, it's not. 1/4 y to the 4, that's better. Power rule, 4/3 y cubed. Add 1 to the power, divide by the new power. Evaluated at 0 up to 4. So f of y, take away g of y squared. That's what 2y squared looks like. That's what a half y squared looks like. Power rule, power rule. 4/3 times 4 cubed. Take away 1/20th times 4 to the power of 5. Take away a whole load of nothings. Learning by my previous mistake, I'm going to let the calculator do this one. So 4/3 times 4 to the power of 3. Take away 1/20th times 4 to the power of 5. You get that, guy? Math 1, boom. 512/15. Bye. Have you noticed that when I do these things on the calculator, the 4/3 has brackets around it and the 1/20th has brackets around it? Do you know why I do that?
To make sure it doesn't do subtract 1, then divide that by 20.
Yeah, it's all to do with the ordinary calculation. Half the time that I put brackets around things, it doesn't matter. It would have worked even if I hadn't. But I've learnt my mistakes in the past that if I put brackets around all of them, I'm going to be safe. Now, give you an example. Suppose I wanted to do 4/3 times 3. That's not a very difficult calculation. 4/3 times 3. And now if I go 4/3 times 3, it's the same answer. But if you do 4/3 times 3/4, prove me wrong. It works for that one as well. I could probably spend 20 minutes not getting one that didn't work. And then the first homework question, I needed it. So I just play safe. Okay, back to this. Are we cool with the process for how to find the volume of a rotated shape and where it's the difference between two curves about the y-axis? You only get like one shot, and this is not dissimilar to the one that you've got. Well, we're now moving to our next section then. There are two quite different techniques for finding volumes of revolution. The 6-2 guys that we've just finished, isn't the formula mostly pi and something squared in a very, very vague general way? There are some situations where this formula doesn't work. It's impossible to do, the math doesn't work, maybe the integral doesn't work, whatever the reason is. You can't get the volume that you're looking for, which is why they needed to find a different way of coming up with the same job. And this is called the shell method. Sometimes it's called, if you look up online, cylindrical shell method, but it's called the shell method. And it does do things quite differently. Oops, excuse me. Sorry about that. Keep my head in. Forget it. My head in's gone. The curve I drew didn't fit what I needed. Let's show you why you need the cylindrical method. Imagine I wanted to take this curve and rotate it about the y-axis. This curve happens to have this equation. Now, this particular one fails in two distinctly different ways, right? It's not doable as a rotation about the y-axis. It's pretty easy to rotate about the x-axis, which you agree it wouldn't be a big deal to do it about the x-axis, but it has a big problem with the y-axis. Problem number one is, this equation is no good to me. Don't I have to rewrite it as x equals some function of y? Would you agree that it would be very difficult, if not impossible, to reconfigure that to be x equals something? Yeah, you can reconfigure some easily. Like, couldn't y equals x squared work, right? That would just be x equals the square root of y, right? Y equals 10x, yeah, I could fix that. Even y equals 10x plus 10, I could fix that. But I don't think I'm going to be able to fix that. So that's the first problem. The second problem is a little bit less obvious. If you're rotating about the y-axis and you do it with the previous method, don't you draw a little rectangle going this way? And won't that be the start and that be the finish? Technically, that would be what your f of y, and this side here would be like your g of y. Well, there's a really major problem with this. There's only one curve. So how can you go from one side of the same curve to the other side of the same curve? And you see, the whole thing just falls apart. So when they got a question like, I need to find out what this volume looks like when you rotate it about the y-axis, the method that we used yesterday, right, just doesn't cut it for lots of reasons. Have I convinced you then that there are situations where you have to have another method then, right? So what does this method look like? I think I'll do it in a new piece of paper. The volume of y equals f of x about the y-axis from x equals a to x equals b is the integral from a to b 2 pi x f of x dx. And no, that is not a mistake. You are rotating the shape about the y-axis, but isn't all the information in terms of x's. Did you see that? Which is kind of back to front, but it's the right thing. That's the one that works. So if I take, for instance, this question now, and it starts at 0 and it finishes at 2, and we're rotating it about the y-axis, then its volume is the integral from 0 to 2, the start and finish on the x's, 2 pi x, this function is called what? 2x, take away x squared, so f of x dx. 2 pi x f of x dx. Okay, now once you've set it up, it's just good old-fashioned integration. But there are some things that you typically do here to make things a little bit nicer. Has anybody any idea what I'm going to do with that pi again?
Put it out front.
Yeah, just get it out the road. What am I going to do about the 2x and this thing? Algebraically, what do you think I should do with the 2x on the outside and in the brackets 2x minus x squared?
Multiply them together.
Okay, 2x times 2x is 4x squared. and 2x times this guy is negative 2x cubed. Are you comfortable about how this became that? Right. Now, at this point in time, it really doesn't matter where this came from. Isn't this just a good old-fashioned integral with polynomials? So it's power rules. So I'm adding 1 to the power and dividing by the new power. I'm adding 1 to the power and dividing by the new power. And I'm going to evaluate it at 0 and at 2. And that's going to get me 4/3 times 2 cubed minus a half times 2 to the 4. Take away a whole load of nothings. 2, 4, 8, 32/3. Take away 8, which is 24/3, and 24, and that one gets me 8/3, I hope. And that's the volume. 2, 4, 8, 32, that looks good. 2, 4, 8, 16, half 16 is 8, 24, 6, 8. I'm pretty sure that's correct. Suppose I did a question and the answer was negative a half pi. How do I know for sure it's wrong?
Because it's negative.
Because it's negative, right? These are still physical volumes. 0 and negatives don't happen in physical volumes. So you be on the lookout for that. Because it's easy sometimes to stick a plus where a minus should go. Are we pretty comfortable about how to rotate a shape about the y-axis then? It's 2 pi, right, x, f of x, right? 2 pi x, f of x. There is a long-winded proof to that, but you can look that up yourself. Question, what you got? Hector.
Is this best used when you have only one equation?
Your audio is not very good, Hector. I'm not sure what we can do about it because I can't really hear what you're saying.
Try writing it down in the chat box.
I don't know if that's possible. That could work. Is there a way of adjusting your? Is it just me? It might be just me that's not hearing it well. Are you hearing it?
I think he asked, is it only used for one equation, or like, is there only, only one equation when you're using this, or one function when you're using this equation to find the volume?
Yes. So this is for a single curve being rotated about the y-axis. Correct. So if that was your question, Hector, your answer is a nice short one. Yes, you are correct. This particular equation is for one curve. Now, what do you do then? This might lead on to it then. What do you do when it's two curves, right? They bit between two curves. So let's see what if I can make a story up that would look like that. Let's have a curve y equals f of x, starting at A. And let's have another curve, finishing at B. And it's going to be called y equals g of x. But the trick here is that it's going to be rotated about the y-axis. So can you imagine this shape being rotated about the y-axis? Oh God, that would be the weirdest looking thing in the world. It would look like a weird donut. Can you imagine a donut that wasn't made very well? I'm not even going to try and draw it because I'd make a mess of it. I can visualize it, I just can't draw it. Can you imagine this little bit here is going to be a little hole, right? And then going round it is going to be this fat, skinny donut thing. Not very pleasant shape. Now, we're going to adapt this formula for rotating the area between two curves about the y-axis. And it's going to be the integral from A to B. Now, You haven't seen this formula, but you might be able to do an inspired guess. It's going to be similar looking, but with an adjustment, right? Just chuck it out, and if it's good, I'll write it down, and if it's not, I'll say, try something else. How do you think it's going to start? Use this fella as your framework.
I think it would be, what is it, 2 pi x times f of x squared minus, or fy squared, or yeah, f of x in this case, minus g of x, or yeah, squared dy.
No squares.
Oh, no squares?
No squares.
Okay.
There are no squares here. There are no squares there. You see, it's basically this guy take away the other guy. Does it kind of make sense now? You see the formula for it? So in my picture up here, we would need, some physical equations to do it too, but I should be able to make one up. I want to keep my life easy, so I'm going to pick ones that are relatively straightforward. Let's do y equals 2x and y equals x squared. And it's from 0 to 2, because I happen to know that's 2, but can you imagine you could put that into Desmos and find all the points that you need? And this shape is going to get rotated about the y-axis. So the volume of this shape would be the integral from 0 to 2. I'd stick the pi outside. 2x. We have an f of x take away g of x conundrum. There's my little vertical rectangle. Which one of these goes first? 2x or the x squared?
The 2x?
And the reason for that is, isn't the 2x the straight line higher up, right? Big guy first, little guy second. Higher up in this case means that way. And so we have a 2x take away an x squared. Does that kind of make sense now, how that would be set up as an integral? I'm just going to go through the rest of it because it's good practice, but hopefully it's not too much of a burden. Distribute the 2x. Power roll. I'm getting deja vu here. Is this very similar to an earlier question for a totally different reason? Probably because I picked simple functions. 4/3 times 2 cubed, take away 1/2, times 2 to the 4, minus a whole load of nothings. 2, 4, 8, 32/3. 8. Oh God, would you look at that? I've got to find that guy now. What one was that? Oh, I can't find it now. But wasn't that the same answer for a totally different question?
Yes, it was the last one we did.
Yeah. Right. Well, you know that 2 different questions could have the answer 42, right? Just because they're the same, it's just coincidence, really. So, single function about the y-axis, area between 2 functions about the y-axis. I think I've got enough time to squeeze the last 2 possible situations in. Suppose, it's not very clear. Suppose you wanted to use the shell method to rotate this area, right, from y equals c to d, but you want to do it about the x-axis. Well, when you rotated things about the y-axis, wasn't everything in terms of x's? So if you rotate everything about the x-axis, isn't everything upside down? So the formula will be the integral from c to d, 2 pi y, f of y, dy. Does that make sense? Right, since I'm running short of room, can we pretend that this curve here was y squared minus y? I know it's not, but let's just pretend it was. And let's suppose it was going from 0 to 2, just for argument's sake, right? Then what you would do in that case would be from start value to finish value, 2y, this guy, dy. But couldn't that start and finish be anything? Could it start at minus 10 and finish at plus 10? I mean, whatever the question tells you, right? So start value of y, finish value of y. The 2 pi y is fixed. And this guy is whatever the curve happens to be called. And I better not get 8/3 out of this one. I better not. Okay. 2y cubed, take away 2y squared. Add 1 to the power, divide by the new power. Okay, keep going. 1/2, 2 to the 4, take away 2/3, 2 cubed. Okay, that's good. I don't think I'm going to get 8/3. I was a bit worried that I would end up with yet more 8/3. 2, 4, 8, 16, that gets you 8. 2, 4, 8, take away 16/3. Oh. Do you know what the answer to that is?
Eight-thirds pi.
Yeah. Oh, God in Himmel. Do you know, if I had tried to do 3 questions that by sheer coincidence, because I just felt like it, were all equal to the same answer, do you know I'd spend days trying to get one to work? But today I'm just picking things off the top of my head, and for some reason 8/3 is coming into my life. So anybody who's got money, 8 and 3 on the lottery ticket, right? Fate is trying to tell me something. 8 and 3 on your lottery ticket numbers. You got that? If you play the lottery, which I don't, but if you do, 8 and 3. Well, for my last example, I am definitely not going to get 8/3 because I'm deliberately going to make sure I don't get 8/3. So, oops. You get x equals e to the y, and you get x equals y, and we're interested in rotating it about the x-axis from 0 to 1. So it's probably there, right? The chances that that is 8/3 pi is 0. I'm just knowing that I ain't getting, yeah, I'm not getting it. So we need to set up our integral. Now, if it's the if it's the volume between two curves from C to D, because when you rotate about the x-axis, everything is in y, so C to D, 2 pi y, won't it be f of y take g of y dy? Agreed? So it's going to be from 0 to 1. I'll pop out my pi. I'm going to do my 2y. And one of these guys is e to the y, right? And the other one is just y. Agreed? Can you trust me that this one is bigger than that one? If you look at my little, these guys, big, small, right? The guy furthest to the right is big. The other one is smaller. Right, dy. It's integral from 0 to 1 of 2y e to the y. Take a 2y squared. This guy I know how to do. This guy you do not know how to do, but we will do a thing called integration by parts in the future, where you will find out how to do that. So can I just tell you what the answer is and you just pretend it's magic, right? The antiderivative of this guy is 2 it's 2y e to the y, take away 2 e to the y. So what do we get? Plug in 1. 2 times 1 e to the 1, take away 2 lots of e to the 1, take away 2/3 1 cubed. That's good. Subtract nothing, minus 2 e to the nothing, take away nothing. That's minus 2. That guy is 2e, take away 2e, take away 2/3. Subtract -2, -2/3 plus 2. Yay, I didn't get 8/3. Okay, will you all say hi? Get your attendance for today. When we turn up tomorrow, I'll actually start using the homework questions from WebAssign on the same topic. But we've seen one of each of the 4 possibilities, right? Single curve y, double curve y. Single curve x, double curve x, right? That's it as far as we're concerned. And we'll probably do one more of each of those tomorrow, using the homework as a guide. And that will be us finished that section. Okay. I'm going to hang about. Anybody who has any questions can do so. The rest of you, bye-bye.
Thank you.
You're welcome.
Thank you.
Okay, thanks.
Thank you.
You're welcome. Hi, Michael, you got a question? Evan, you may have a question. I don't know yet.
Oh, I'm fine. I was just making sure I got mine in.
Okay. Evan, you got a question?
No, I just wanted to say hi.
Hi. Well, I can see you're saying hi, so you are good to go then if you have nothing.
All right, cool.
Okay. Mark, do you have any question? Hector, do you have a question?
No, it's just that my internet was kind of slow today. I live in the woods in Germany, so sometimes it's really slow. But the question I had, it was answered. It was the one about using the second equation. Can you hear me a little bit better now?
A little bit. I think it helps when there's not another 20 odd people sucking up the bandwidth.
That could be it. But yeah, that was everything was answered. So yeah, thank you.
Okay, you're good. Mark, do you have a question for me?
Yeah, the only thing that's a little confusing is like the setup, like knowing which function, the g of x or f of x.
Right,
Goes
which one
first.
is which, essentially, right?
Yeah.
So if you do it in the X format, right? So you have
Mhm.
two curves, and I'm making these guys up. Suppose this one is y equals,
Oh wait, I can't see your screen.
I'll recreate it. Here we go. So I'll keep it as generic as I can. So suppose you have two curves. I'm just going to call them A of X and B of X, right?
Mhm.
So I'm not giving them any title yet. When you look at the curves in this format, imagine a vertical line going from one side to the other. Whoever is the highest, meaning furthest, is going to be your f of x, and whoever is here is going to be your g of x. And that is a truism whenever you're dealing with things that are functions of x. So if it's y equals sine x and y equals x cubed, put them into Desmos if you can't really see them. The one that's highest up is going to be your f of x, the other one is going to be your g of x. And it doesn't matter if you're rotating about the x or the y axis, it's the same relationship, right? The guy that goes first is the taller one, the higher up, and the one that goes second. If you do this way, so basically these are going to be functions of y. So this will be things like x equals the square root of y and x equals y squared plus y, that kind of look to it. Then you're going to look at rectangles joining them this way. And when it's y's, both situations, the one that's furthest to the right, he is going to be your f of y. And the other one, he's going to be your g of y. So the reason why that works is, although that is going this way, isn't that the biggest x value? And when you do it this way, isn't that one the biggest y value? Don't know if that helps or not, but so when x's are involved, the higher up one is your f of x. When the function are in terms of y, x equals y squared, x equals y plus 1, whatever. The one that's furthest to the right is your f of y, and the other one is your g of y. Now, although we use different formulas, for instance, one of the formulas does this. That's sometimes called the disk method. That was like Mondays. And sometimes, oops, there's a pi here, right, and an integral. And sometimes the formula looks like this. But you notice it's still first and second in both cases.
Can you scoot your page up a little?
So
Thank you.
first and second. Now, if you do it the other way, wouldn't that just be f of y, g of y, f of y, g of y? And if you go even further back, remember those questions where we're trying to find the area between two curves? It's the same relationship.
All right.
So high up is f, low down is g. Furthest to the right is f, the other guy is g. Up and down is for x's, left and right is for y's.
Thank you.
Okay. And if that is us, then we'll call it a day.